Today let's look at parallel and perpendicular lines. Our objectives are to identify parallel lines, find equations of parallel lines, identify perpendicular lines, find equations of perpendicular lines, and determine if two lines are parallel, perpendicular, or neither. So let's start with our parallel lines. First of all, let me draw you a picture of two parallel lines, and I think most of you would say, "Oh yeah, I see that, those are parallel lines." Let me remind you what that means. Those two lines will never cross, even if you continued them infinitely far. That's what parallel lines are. But let me ask you this question. Without looking at that picture, is there a way for you to know if two lines are parallel? And the answer is yes, there is. In mathematics, we can know that two lines are parallel if their slopes are equal. And if you'll look at those two parallel lines, I think that makes sense. Those lines look like they slant or tilt the same amount. And remember, that's all that a slope measures, is how much a line tilts. So let's look at two lines and identify whether or not they are parallel. Well, if we look at these two lines, without even graphing them, we should be able to tell whether or not they are parallel lines. First of all, we need to look at their slopes. This one has a slope of -3, and so does this one. Once we see that those slopes are identical, it really doesn't matter about the rest of the equation. We're simply interested in the slopes. So once their slopes are equal, we know that those two lines are indeed parallel. Let's continue now and do some more with parallel lines. First of all, we would like to write a slope-intercept equation of a line that is parallel to y is equal to 4x minus 3, passing through the point 0, -7. Now this has a lot of similarities to what we did last lesson, except we didn't have that parallel part added in. So let's talk a little bit about that. If I want to write an equation of a line that is parallel to this line, what I need to know about this line is its slope. Well, it's a 4. If I want a line that's parallel to it, I want a line whose slope is also 4. So I could simplify what it is I'm trying to do by saying I am trying to accomplish writing a slope-intercept equation of a line that has a slope of 4 and passes through the point 0, -7. Let me remind you what your choices are for how you can write that line. Your two choices are slope-intercept form, y is equal to mx plus b, and point-slope form, y minus y1 is equal to m times x minus x1. Let me also remind you that because we have a 0 right here, we have a y-intercept, which gives us the right to use this one. Therefore, all we need to do is plug in our slope and our y-intercept, and we would get y is equal to 4x minus 7. Let's continue now with another parallel line problem. This time, I'd like for you to write a slope-intercept equation of a line that is parallel to y is equal to -2x plus 3, passing through the point -2, 4. We need to first examine the slope of this line right here. Its slope is -2. If I want a line that is parallel to it, the line that I want also has a slope of -2. Once again, let's simplify what it is we're trying to accomplish. We want to write an equation of a line that has a slope of -2 and passes through the point -2, 4. Now, if I had given you that much information based on the last lesson we had, you should have been able to do that for me. Remember, your two ways to do this are using slope-intercept or point-slope. Because we do not have a y-intercept, we are tied to using point-slope. So we need to plug in our slope and our x1 and our y1, and we get y minus 4 is equal to -2 times x minus a -2. When simplified, that gives us y minus 4 is equal to a -2 times x plus 2. Y minus 4 is then equal to -2x minus 4, and when we add 4 to both sides, we get y is equal to a -2x. Now our instructions were to write this as a slope-intercept equation. Have we done that? Let me ask you, if it's a slope-intercept equation, we should see a slope, which we do, and we should know what the y-intercept is. Do we? Well, let me remind you, you may not see it written there, but because you don't see it, I know that the y-intercept is indeed a 0. So this is written in correct slope-intercept form. Now let's look at perpendicular lines. First of all, let me remind you what perpendicular lines are. Perpendicular lines are lines that cross at right angles, meaning this angle right here is a 90-degree angle, as are all of these other angles where they intersect. So all four of those angles are 90-degree angles. Now let me ask you a question. Can you guarantee me by looking at that picture that one of those angles is not 91 and the other one 89? If the answer to that is no, and it should be, then we need a way of mathematically determining if two lines are perpendicular, and we have it. Two lines are perpendicular if their slopes are negative reciprocals. And I need you to hear both of those words. They're both equally important. Negative reciprocals. What the negative part tells us is that the signs of the two slopes must be opposite. One of them must be positive and the other one must be negative. And a reciprocal we usually think of when we talk about fractions, but what it means is that if you were to have a fraction 2 over 3, the reciprocal of that would be 3 over 2. It flips. So let's look at a pair of lines and determine if they are perpendicular. The two lines are y is equal to a negative 1/4 x minus 2 and y is equal to 4x plus 4. We need to examine the slopes. The first one has a slope of negative 1/4. The second one has a slope of 4. There are two questions that must both be answered yes in order for these lines to be perpendicular. The first question is, are their signs opposite? The top one is negative, the bottom is positive, so they are indeed negative. And the second piece is, are they reciprocals? If you flipped 1/4, you get 4 over 1, or just 4. You don't have to see that 1 written right there. They are indeed negative reciprocals. So these two lines are perpendicular. So let's look at one more set, since this one's a little bit more complicated. Here's another set of lines. We want to know, are these lines perpendicular? Once again, we need to examine slopes. Here we have a slope of 2/3, and here we have a slope of negative 3/2. Signs are opposite, numbers are flipped, so we do indeed have negative reciprocals. The two lines are perpendicular. Now this is going to get a little bit more interesting now. Let's look at some more perpendicular lines. What we want to do now is write an equation of a line that is perpendicular to y is equal to 4x minus 3, passing through the point 0, negative 7. If we're going to talk about a line that is perpendicular to this line, it's essential that we know what the slope of this line is. It is a 4. If I'm going to write the slope of a line that is perpendicular to this, then I need it to flip and be opposite. So the slope I'm looking for is going to be negative 1/4. So let's simplify once again what it is we're trying to do. We're trying to write an equation of a line that has a slope of negative 1/4 and passes through the point 0, negative 7, which by the way happens to be a y-intercept. Once again, you have these two choices for writing that equation. Because we have a y-intercept, we can use this one, and so our equation would look like this. Y is equal to a negative 1/4 x minus 7. Let's take another one now. What if this time I ask you to write an equation of a line that is perpendicular to y is equal to 4x minus 3, passing through the point negative 8, 2. And I don't know about you, but by now you ought to be getting a feeling that when you see this thing right here is not a 0, you go, doggone it, she's given us another one of those. And that's exactly what I've done. So let's look at this line right here. It has a slope of 4. Remember, a line perpendicular to it will have a slope of negative 1/4. So, to simplify our task, we're trying to find an equation of a line that has a slope of negative 1/4 and passes through the point negative 8, 2. Once again, I'll remind you of your two choices, and this time, because we do not have a y-intercept, you're forced to this choice. So it's y minus 2 is equal to a negative 1/4 times x minus a negative 8. That'll simplify to y minus 2 is equal to a negative 1/4 times x plus 8. So when you distribute here, you get y minus 2 is equal to a negative 1/4 x minus 2. We add 2 to both sides, and that gives us y is equal to a negative 1/4 x. Once again, let me remind you, you have a slope of negative 1/4 and a y-intercept of 0. Now let's continue looking at perpendicular lines, and this time we want to write an equation of a line that is perpendicular to 2y plus 4x is equal to negative 8, passing through the point 0, 5. This time we need to examine what the slope of this line right here is. I need to caution you here to be very careful, because remember, before you can identify the slope, it must be written in the form y is equal to mx plus b, and this one is not. So what we would need to do here is solve for y before we can continue. Our steps would be subtract 4x from both sides, and then divide everything by 2. That would give us y is equal to a negative 2x minus 4. Now you can tell me what the slope is, and it is a negative 2. But remember, we want a line that is perpendicular to that. That means we need to change its sign and flip it. So the line we're looking for will have a slope of m equal to a positive 1/2. Let me remind you once again, here are our two methods we can use for writing an equation of a line, and here's our task. We need to write a line that has a slope of 1/2 and goes through the point 0, 5. Well, I hope that you're looking at this going, yes, right there, we can use this. And so our line would look like this. Y is equal to 1/2 x plus 5. Next, I'm going to give you a problem where I ask you to identify if two lines are parallel, perpendicular, or neither. And here are your two lines. Now before we actually start calculating anything, I want to ask you just to look at these lines and form an opinion. Are they going to be parallel, perpendicular, or neither? If they're parallel, their slopes will be the same. If they're perpendicular, their slopes will be negative reciprocals. And if it's anything other than that, they are neither. In order to answer this question, we'll need to calculate the slope of both of these lines. Let's start with the one on the left. We'll begin by subtracting 5x from both sides, so we have negative 2y is equal to a negative 5x plus 6. We then will divide everything by negative 2, and that will give us y is equal to negative divided by negative is positive 5/2 x minus 3. Let's notice here what the slope is of this line. I see the number in front of the x is right there, so our slope is 5/2. Now let's calculate the slope of the other line. Once again, it's not solved for y, so we need to do that. We'll begin by adding 5x to both sides this time. So we get 2y is equal to 5x plus 4, divide everything by 2, and we'll end up with y is equal to 5/2 x plus 2. What's the slope this time? 5/2? Tell me what you now know about the two lines. They are indeed parallel lines. By the way, it's not what I would have guessed if I had been guessing to start with. Let's do another one of those. And our two lines this time look very similar, but I have made some changes. Question is still, are they parallel, perpendicular, or neither? Let's start with the one on the left. We'll subtract 5x from both sides, divide everything by negative 2, and get y is equal to 5/2x minus 3. Our slope this time is still 5/2. Now let's look at the other one. This time we'll add 5x to both sides, we'll divide everything by negative 2, and we end up with y is equal to a negative 5/2x minus 2. The slope this time is a negative 5/2. The question then is, are the two lines parallel, perpendicular, or neither? Well, their signs are truly opposite, but they are not reciprocals. Therefore, these two lines are neither parallel nor perpendicular. I know sometimes you get bogged down with all the stuff we do in math, so I just want to remind you, everything has its beauty, but not everyone sees it. Slow down and see it. Have a great rest of the day, and I'll see you soon.